Okay guys, in this quick video I'm going to show you how to interpret the fracture surface. You remember we got our sample and there was first piece of information associated with this sample, the amount of energy that was absorbed during fracturing, and that was 150 joules. So the next piece of information is how much ductility or cleavage we see in our sample. In other words, how ductile it is relative to its appearance of its fracture surface. So here we have a chart with the two spectrums of how the fracture surface may look like. So this is the beginning and this is the end. So we're going this way here with this particular chart. And as you can see here for this sample, we see no geometrical change of its cross section. So it means that this sample was fractured with 100% cleavage, or in other words, it was brittle. So the other side of the spectrum is this example. So you see that there is a dramatic change in shape. So the fracturing of this sample was accompanied by a lot of plasticity and plastic deformation. So as you can see, the ductility here is seen like across the whole section. And now we see all different options between these two critical points. And when you here, for example, you see that the amount of ductility is decreased, and then it goes lower and lower until there is no ductility, and the sample fractures in a brittle fashion. So cleavage, 100% cleavage. So as you noticed, maybe this shiny appearance of fracture surface is going down. You see the surface area that is related to brittle fracture is reduced when we go from right to here to the left, and there's very minimum brittle fracturing appears here, and no, like 0% of cleavage here, so 100% ductility. So let's just try to assess our sample. So here, as you can see, this lower portion of the sample is really shiny, and it represents some brittle fracturing. So the upper portion, you see this shear lips was fractured mostly in ductile fashion, so it is associated with some plastic deformation, and therefore you can kind of draw the boundary between these two regions and see what situation, what case we shall have here. I believe it is something maybe between this, and I believe it is more of this case. So it is around 40% ductility we have here going on, and 60% brittle fracturing. So always start to look at the surface, kind of excluding the notch area. You see this little region, so therefore that would be true. I would say 60% of this brittle fracture and 40% of this ductile fracture. Okay, thank you, and see you next video.